All right, general math, we are on 10.4 using Pascal's triangle to solve combinations. So to create a Pascal's triangle, we are going to flip a coin, and then every time we flip the coin, we have a 50% chance to flip heads or tails. So if we start at the top and we flip a heads, we're going to go to the left, and if we flip a tails, we're going to go to the right. So here's the first row, right? We just start with 1, and then we have two different options, right? We have two different options, and we could either flip a heads or a tails, so that's 50-50. Well, half of 2 is 1 and 1, right? So let's say we flip a heads. And then if we were to flip a heads again, that would go to the left. If we were to flip a tails, that'd go to the right. But let's say we flip a tails. Well, if we flip a head, we're going to the left, and tails, we go to the right. So we have two different options, right? Because we came to the middle twice, and then one option down here. So there'd be a 1, 2, 1. And then the fourth row, we would just keep continuing this pattern over and over and over. And that's how they got all these numbers in the middle. Okay, you don't have to worry about making this, but maybe that visual helps you understand it a little bit better. So the nice thing about Pascal's triangle is that when we have really big combinations, we don't have to plug them into that ugly formula we use in 1.3. We can just use the rows or the columns and then the rows from Pascal's triangle. So if we had a 5 choose 3 combination right here, we would start in this box right here. We don't use the furthest boxes to the left. We're starting right here at the 1. We would go to the 5th row and then go to the 3rd box. So box 1, box 2, box 3. This is our 5 choose 3. So our answer to the combination would be 10. So yeah, like just to reiterate, we don't use the furthest boxes on the left. We start right here. I kind of drew the line for you so you can forget everything to the left of this line. Starting here, 1, 2, 3, 4, 5, box 1, 2, 3. And then the last problem we have, it's kind of tricky. So we have 9 offices to fill in the Supreme Court, 9 spots. We have 6 Democratic candidates and 13 Republicans. Okay, so from those 6 Democrats, we want to choose one. So we have a 6 choose 1 problem. And then out of those 13 Republicans, we want to choose 8. So we have 13 choose 8. Well, the 6 choose 1, let's go back up here. Let's go down to the 6th block. And then the first block is 6. So our answer to this combination is 6. But we don't have a 13th row up here, right? So if you don't have a problem that fits on the picture above, just Google a bigger Pascal's triangle. The numbers were too small to fit on the Word document. But 13 choose 8 is 1,287. So if we want to do these together, we have Democrats and Republicans. We need to fill these 9 offices. We're just going to multiply both of these different combinations. So 1,287 times 6, that means there's 7,722 different possibilities on how to fill that Supreme Court.